Okay guys, what we're going to do now is cross multiplication. Okay, and you guys have done this plenty of times in the past. I want to use an example to talk about it first. So for example, if we have 2/4 as a fraction, we know that that is also equal to, for example, 10/20. Okay, these are two fractions that are equal to each other, and these ones are quite clearly equal. I know that this is a bit of an easy one, but we can put that into what we call a ratio table. Okay, and your ratio tables look like this. So you have here 2 and 4, and here 10 and 20. And as I said, I hope you've already used this plenty of times because you use them quite a lot in chemistry. You'll use them also probably in physics and also in geography, so I assume you're pretty familiar with them already. But if you're not, the way a ratio table works is the ratio between columns and rows in the table stays the same. So for example, the ratio from 2 to 10 is times 5. Okay, that means from 4 to 20 is also times 5. Okay, we can also go down. Okay, we don't just go across the ratio table, you can also go down. The ratio from 2 to 4 is times 2, and therefore from 10 to 20 is also times 2. And we can use these relationships in order to find unknowns and missing things. Okay, so in chemistry you might use this to convert between different ratios of a substance. Okay, you want to know how many grams of something you need for your reaction, then you're going to use a ratio table. All right, you might use it in geography in order to calculate the scale of something, how big something is in real life if it's however many centimeters on the map. Okay, so this is when we use cross multiplication, okay, and ratio tables. So let's do an example of how we can use this. So if we have a ratio table like so, okay, and in that ratio table, let's say that we have 2, 3, 5, and x. Okay, so we want to know the value of that x. Now, what we can do is simply cross multiply. This is called cross multiplying, where you multiply things up to the opposite side of the table. Okay, so what we're going to have here is 2x is equal to 3 times 5. And you guys know that this ratio table also represents, or it's the same as saying, 2/3 is equal to 5 over what? Okay, this is what our ratio table is saying here. Okay, so we've cross multiplied. We have 2x is 3 times 5. So 2x is 3 times 5 is 15. Okay, then all we have to do is solve this. So we're going to divide both sides by 2, and we're going to get x is 15 over 2. Okay, in this case you can simplify that to 7.5. Depending on what you're doing, sometimes it's not necessary. If you're finding a length, then we prefer it to be like this. Okay, if you're just trying to find x, you can leave it as 15 over 2. That's absolutely fine by me. Okay, so these are pretty straightforward. Sometimes you might get something a little more complicated. So for example, you might get a ratio table with, say, x plus 1, 6, 3, and I don't know, I'm just making something up here. Let's put a 11 in here. Okay, so we're going to again cross multiply. Now when you cross multiply here, you need to be careful because the x plus 1 is a whole term. You're multiplying 11 by the whole thing, therefore you must use brackets. So 11 brackets x plus 1 is equal to 6 times 3. Okay, and here the obvious first step is to expand your brackets. So we're going to have 11x plus 11 is equal to 6 times 3, which is 18. Okay, with algebra, our first step is to minus 11 from both sides. So we get 11x is equal to 18 minus 11, which is 7. Now we're going to divide by 11. So we get x is equal to 7 divided by 11. Okay, so that's it. This is as much as we're going to do today. Sometimes you might also find that we do have situations where there are more than one box, or there is more than one box that has an x in it. So we can have x plus 3 here, we can have 2x minus 1 here, and then 4 and 6. Alright, so in this case, when we cross multiply, you will find that we end up with 6, and then remember the brackets, x plus 3 is equal to 4 brackets 2x minus 1. And you guys should know how to solve these ones quite easily. Okay, so we get 6x plus 18 is equal to 8x minus 4. We are going to minus 6x from both of these. I always choose the smallest variable term. Okay, it's fine if you do it in a different way, but this is the way that I like to do it. The important thing is that you show your steps. I don't care how you do it as long as you show your steps. And it's correct, of course. So we're going to get here 18 is equal to 8 minus 6 gives us 2x minus 4. Okay, our next step is to add 4 to both sides. So 18 and 4 is 22 is equal to 2x. Okay, and our last step is to divide by 2. Now, we always also finish with the x on the left. I don't mind if you first do the step and then write it around the other way, but make sure that at the end you always have the x on the left. So here we have 11 is x, so x is equal to 11. And as I said, I don't mind if you skip this one here. Okay, you can go straight to x is equal to 11, that's totally fine. Just make sure you finish with your variable on the left. Okay, it's just one of those maths conventions, the same as a lot of things. It's one of those things that we ask you to do. Okay, so that's working with ratio tables.